Yes, sir, you are.
Okay, okay. I just started the recording. Okay, so hi. So before we can actually move ahead, I just want to get a recap. And did you guys go through the resources I shared?
Yes, sir.
Yes,
Okay, okay. So can anybody summarize what did you find? Some feedback. Were they helpful? Were they not? We need more time. What did I? Are the resources very short or too long? What?
The basics of programming one was very succinct. Like I felt like I got everything that they were trying to teach.
Okay. Basics of programming, you liked it. Okay. Uh, yeah, that's the only resource I shared. Other one is a 5-minute video. Did you guys all do the basics of programming? How many of you have done it? Did not do it? We can just be frank.
yes, I have opened my R Studio and did the same coding test. So, fine.
Okay. 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 How about Subarna? Were you able to? Hello, Subarna. We cannot hear you. Okay. Even if you did not do it, I hope that once you go back, maybe after this session, you'll get a little more hang of it, right? Okay. Today we'll be starting with the second session, and this one will be a little more in depth on exploring data with R. But before I forget, there are some very important things that I'd like to, uh, make it clear, right? The first thing is that R is case sensitive, right? In the sense that when you write, if you remember yesterday, last session, I asked you categorically don't use spaces, right? When you're naming things, and that's an industry standard. That's how it is. You should never use spaces when you're programming. But there are other ways you can write. For example, you can fill the space with an underscore, or you can fill the space with a hyphen or a dash. I'll not go into the very nitty gritties or uh, what is the best one, which one is better, and what should be the norm and things like that. For a beginner, you should understand that all programming needs to be done in an lower snake case. You see this snake that is there. You're able to see my cursor, no?
Your screen is not visible.
Oh, my screen is not visible. Okay. How about now? Am I
Yeah, now it is.
okay?
Now
It's
it is.
visible, right? Okay. So yeah, this is what I'm trying to show you, that um, the snake case is the one that we tend to say that is the one that needs to be used, especially when you're a beginner, and not just a beginner. When you're working in R, a lot of things will get very streamlined when you consistently use this case, right? Anything that you start with has to all be in lower cases, and any space should be substituted with an underscore. Yeah, snake case is the best. That's what I wanted to say. It already is eaten the camel, so it's actually one of the industry standards. But today, what we'll be talking about is exploring with data. So we're going to do exploratory data analysis, a bit of EDA. The, what we'll be talking about is what exactly is EDA, and uh, how to generate questions about your data, and how to search for answers by all these processes of visualizing, transformation, and again, it's an iterative process. You'll understand. If time permits, we'll do a live demo. But let's come to the basics. What is EDA? EDA stands for exploratory data analysis. It's a lot of things, and it's not a lot of things also. Incidentally, it's one of the critical things that you do whenever you do embark on your data exploration journey. Is the critical first step. But you should not think of it as a check mark or a step to do. It's more of a state of mind, in the sense that exploring your data has to come up with means that you have to come up with questions and explore ideas about your data. And there are no strict rules about it, but the process helps you understand your data better, so that you query your data, you come up with questions, interesting things that you can ask, and then the data will itself reveal itself to you. You'll identify patterns, seasonal patterns, or interesting trends, or different associations, different subgroup analysis you can do. But it also helps you to understand your data better, and also it's more of a creative process. Right? It's an iterative cycle that you need to do. But just to give a formal introduction of what EDA is, the book on EDA is written by John Tukey, and he calls it, detective work. It's a numerical detective work, which can also be, a tabular form or a graphical representation, but it's still a detective work. You need to find out things. Data does not want to reveal itself to you, but you need to, go find your ways, to make it speak. But what he talks about is EDA being mostly a philosophy, right? Where researchers examine the data without any preconceived ideas, and we come up with hypothesis, but we want to test that hypothesis. We don't say that, okay, whatever we are thinking is not really happening there, so that means the data is wrong. No, that's not the conceived ideas that you need to have. You have to be a little open about it, and you need to also engage with what story the data can speak to you. There are other definitions of, not definitions, some guidelines on how to do EDA. So the easiest way to do exploratory data analysis is to use questions as your tools. And when I say questions as your tools, is that you come up with a idea. You come up with, okay, what if this is the scenario? How would I explore this? And EDA is most important part of data analysis, even though you already know the questions. But for example, the key to asking the right question is also important. It's very important that the questions you ask are also meaningful, and you should also be aware that some of the questions might not be answered with the data that you have, and all that needs to be taken into account. And for example, I think it's asking the right questions is important, and the key to asking the right or quality questions is to generate a large number of questions, right? To come up with multiple hypotheses and try to test it. And then, though it's difficult to ask the important or the most important question right from the start, but you'll come to know about the process, and you'll get to know the data much better. And each question that you ask will make the data reveal itself a little more. So that way you're increasing your chances of making a sizable discovery of what the data is holding. And what questions to ask is also important, right? In the sense that, for example, the kind of questions you really need to ask is what kind of variations are there within your data. And I'm sure that right now everybody knows what the principles of tidy data is. At least say yes or no.
Yes, sir.
Yes,
Okay.
sir.
Okay. So
Yes,
I'll
sir.
just repeat what tidy data is, right? A tidy data, just for the sake of Anand. Tidy data actually means it's a rectangular representation of data. It's a concept that is brought out by Dr. Hadley Wickham in his seminal paper in 2014 called tidy data. And what he says is that the representation of data is done by three golden rules. The first rule is that all variables are columns, and all the second rule is that all observations are represented as rows, and all values are represented within the cells. And you will come across this data, this concept ID data again and again. We'll ensure that we are doing that so that it's ingrained within you. The second kind of questions you can ask is what kind of covariation occurs between your variables. It's not just within your variables, but between variables, is there any kind of covariation or covariance present? And then you should also ask the question that, okay, some of the questions that you really want to ask might not be answered by the data that you have. For example, I'll just tell you, because we are talking about public health data and a lot of data is available, right? Much of this data is actually being collected for the purpose of administration. And the right answers, right questions, or the necessary questions that the program managers have at the local level, who is, collecting this data, when he wants to find out a question, okay, which village is the one I should focus on? But that kind of questions can not be answered by the data that they are collecting. But this data collection purpose is for the people sitting on the top at the center, right? To actually look at a bird's eye view of what's happening. But that there are a lot of issues. Things will change in the future about this, and a lot of work is also being going on. But the other thing you need to keep in mind is the quality of your data, right? You might have your data, but you really, if you don't really trust your data, then there's no point in even looking at it, right? If the quality generalize it, you remember the concept, 4 things that we talked about, right? The reproducible research. So the principles of reproducible research won't be fulfilled when the quality of your data is not robust enough. So what did we cover yesterday? Sorry, last session is that I missed this part. We have not covered this visualization using ggplot. We'll do that at a different time. I hope that the first session everybody would be able to join, and then we could cover this in the last session. But I see that even Frederick sir could not join today. But hopefully he'll be able to actually look at the videos. But we had a good enough sense of what health data science is, what reproducible research is, and what ID data is. I touched upon what health data science is in very brief this thing. I did not want to give you much more in-depth, waste our time in in-depth discussion, but we'll come to that whenever we get a chance to talk about it later on. But we definitely talked about how to import data, and there are other packages and different types of data. SPSS data you can import, SAS data you can import, Stata data you can import, and all of that is possible. And then we talked about this package called here, right? The other package we talked about was tidyverse last time, and but this time today we'll be talking about a few other things. We'll be talking about how to prepare your data in a tidy way. What is the difference between data cleaning and wrangling? And they're really interchangeable, but then when you do it using the tidy principles way, you really call it wrangling. And then we'll also talk about data exploration, and we'll be talking about what data transformation is and how to visualize your data. We'll not be talking about the statistical analysis and summary tables in this session, because I don't think so we'll have much time here. But we'll come back to this in the next time. So before we move ahead, if you remember, I have spent quite a bit of time in explaining that every data science project needs to be started as a project. And the way you start a project is you go to your RStudio window, and then on the top left corner, there is a button called File. Once you press that button, there is a new option called New Project. We'll create a project, and then we'll see how to do with that later on. But if you prefer, I'll just unshare this and then share my R Studio. Can anybody tell me which screen are you seeing now?
Your R Studio, sir. That is.
Okay, you're seeing my R Studio, right? Should I increase the font?
Yes, sir.
Is this any better?
It's now
Yes,
better.
sir.
Okay. So this is how R Studio looks like. I'm sure everybody must have known. This is called the script pane, where all your working scripts are, here. There are n number of file types that you can create. If you go to this plus button here, there is this R script, Quarto document, Quarto presentation, R notebook, R markdown, Shiny web application. You can create a Plumber API also, a C++ file, Python, SQL, Stan, D3, anything that Julia, anything that you can think of, you can really integrate within this own window. And when for example, if I want to create a script, I can just press this R script and then this untitled 1 and 2. This is how it opens. And you see there is this small R button. I'm not sure if you can appreciate that, but you can see this logo R here. That shows that it's an R script. But we were trying to talk about projects, right? So the way you create a new project is you would go to File, and once you go to new File, there is this New Project option, yeah? And then it's the second in the drop-down menu, and then you press that. The moment you press that, it's going to open a new pop-up kind of a window. You're all seeing this, right?
Yes.
Okay. So it asks you to create a project, and there are three places or three things you can do to create a project. One is you can create a new directory and say that this is where my project is going to reside. Other thing is that if you have an existing directory, you can choose an existing directory and you can place your project. The third one is when you're using a version control, in the sense that you have a previous project that you have been working on, and then you want to work on that a little further. This is, how many of you have heard the term GitHub?
I have heard, sir.
Okay. Who is that? Okay. Lokesh has heard GitHub. Anybody else?
Sir, I have heard. Suborn.
Okay. Subarna also has heard. Okay. 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 GitHub is a way of, okay, maybe you can Google it. Google might be giving you a better answer. It's called GitHub, GITHUB. Okay. Okay. For now, we'll be starting a new directory. New directory. When I press new directory, it is going to ask me what kind of project do you want to create, right? It's a new project. Do you want to create an R package? Do you want to create a Shiny application? Do you want to create a Quarto website, a blog, a book, or do you want to do a number of things, right? There are many things that you can do within this project itself. So for now, I will choose new project. And the moment I choose new project, it will ask me, where do I want to create this? I can create this as a subdirectory of. For now, I'll choose IPHA. So PHDMI IPHA is my subdirectory. In this, I want to create a new project. Please understand that whenever you're creating a project, let that project name be little meaningful, because later on when you're searching for it, that 1 or 2 words should be enough for you to search. Okay. So for example, today's project, I'll be calling Exploring Data with R. I'll call it Exploring Data with R. Okay. I'll create a new project. I can open it in a new session. Let me open it in a new session. the moment I say open it in a new session, it will start one more R Studio for me. It'll just take a couple of minutes, but then see, ignore. So it has, this is what it looks like, right? When you create a new project. How do I know I'm within a project? I know that I'm in a project because this top right corner is saying that exploring data with R. Are you able to see this wherever I'm pointing my cursor?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So whenever you open R Studio, for example, let me open R Studio here. I'll just open, I'll just type in R Studio and I'm hitting enter and it'll open one more R Studio. But whenever I open R Studio, the project will be none. Okay. So for example, this, see, the project is none, correct? But I have to ensure that I'm always working within a project. So if I want to create a new project, I can create a new project this way. If not, if I have been working on this project from before, I can just press this down arrow button and all my previous projects will be available here. Not all, at least the first 10 or something. So this is the project I was working on. I can just click on this and then it will open. Okay. So I'm closing this just for now. So this is the project that we're working on. Whenever we created we create a project, if you remember last time I showed you a small cartoon of safe and R-Prods, very metallic, sturdy thing and a very glass-like set working that way. So if you remember, we were talking that time of a file name called R-Prods, P-R-O-J. So whenever you create a project, this is what it creates. It creates this R-Prods file, correct? So this is the only thing that is for now created, but it tells you that, okay, this is where your project is residing. So if I want to start working on anything, I would like to, for example, create a new R script. I can just simply create an R script here, just new file, and then I can just create R script. And I would like to, this is my first R. This is my first R script. Whenever I'm writing in an R script, now this is one of the good habits or code hygiene or whatever you can call it. The first line of any R script should tell you what the R script is doing. Okay. Sometimes we'll just write clean data .r or something and save it, but we don't know what data it's really cleaning, right? So we have to always, it's for yourself. When you come back, you want to look at what this code is doing. The first line will tell you what the script is telling you. Okay. And then what is the first thing that we do when we open an R script? We'll load packages, right? Isn't it? Which are the packages we
Yes,
like
sir.
to load? Yeah. If you remember, you know what a package is like. It's like buying a book from a shop, but keeping it in your desk, not desk, your book rack. And in order to read that book, you'd like to bring that book on your table, correct? So the function that you use to bring that book to your table is called library, isn't it? So there are two libraries I'd like to use today. The first one was tidyverse. Okay. The moment I press tidyverse, it's going to load 8 other packages for me. Okay. What are the packages? ggplot, tibble, tidyr, reader, per, dplyr, stringer, forecast. Okay. The second library I would like to use, load, is library here. Okay, what is here doing? Here is setting your working directories, right? It is going to help you manage all things, right? So the moment I run this, it is going to say that here starts at C users Arun Dropbox PHDMI IPHA exploring data with R. Okay, so that means this folder is where my working directory is. Correct. So if I want to find out what my working directory is, I can go to this files pane. In files pane, there is this gear button. I can press on this gear button, and then a lot of options will open. In this, I can go to my working directory, or show the folder in a new window, or copy file folder path to clipboard. All these options are available, right? Next, the other thing I wanted to show you was how okay. This here is also going to give you this. So you can use R like a calculator. I'm sure that all of you have done that, tutorials, right? Primers. If you want me to move away with this and get on with stuff, then you can just let me know, because I'm not sure how comfortable you are. Anyway, I'll just take some 2 minutes. R can be used as a calculator. 2 plus 2. What is 2 plus 2? 4. Okay. I hope everybody knows how I am running this command. The line number 9. I just go to line number 9 and press Control Enter. Okay. The moment I press Control Enter, in my console, that particular line is going to run, and it is going to give me the answer. Okay. If you see in the bottom environment pane, right now my environment is empty. Okay. What I can do is I can create a new object here, and let me call this X. Okay. If I want to say that X is 10, I will do an assignment operator. The assignment operator in R is less than symbol and minus. Okay. Less than minus. I'm sorry that I have enabled one particular font. I'll just remove that font for now, so that you will be able to. Okay. The assignment operator is less than minus symbol. Okay. Less than minus means whatever is there on the right side of this is going to be put in something named as this. Okay. I can say X is 5 and then Control Enter. The moment I press Control Enter, in my environment pane, which is right now empty, it will create one variable, not a variable, one object called X. So X is 5, isn't it? But if I say what is 2 times X, again, times, I cannot say 2X, I can say 2 times X. What is it going to be?
10.
10. Okay. You get my point? If I want to say, yeah, sorry. Yeah, Parthi.
No, sir, I didn't take.
Okay. So I can say X by 2. What will be X by 2? X divided by 2?
1. No, sorry, 2.5.
2.5, isn't it? So it can use it like a calculator, but you can also say that X now is 10. Okay. And you see the value here has changed to 10. And then if I run 2X, it will be 20. If I run X by 2, it will be 10. Sorry, 5. Okay. So this is how you can, assign values within R. And you can also load your own data. You can just go to this. In the environment pane, there is this option called import dataset. The moment you press import dataset, you'll be able to load your own dataset. You can just go here and do whatever you want. But this is not what I want to show. Let us work with some dataset that is already available. There is a dataset called, the moment you press data in R, there is an option saying that, all these datasets are available for you. Okay. These are all inbuilt data sets. You can choose anything you want. I can choose low birth weight, or let me choose one of the common ones, maybe empty cars. The moment I say data empty cars, this empty cars data is present here in my data. Okay. It says promise because right now I have not loaded it. I should have, if I would have said data frame equals to empty cars, then it will create a data set called empty cars. And then I can say df.
I'm sorry, sir, but can Mr. Lokesh like just mute because it's too much noise?
Yeah. Okay. So if at all I want to find out the class of data frame, it says it's a character. Sorry. Class of empty cars is a class of empty cars is a data set. I can find out what are the dimensions dim of empty cars. There are how many rows? 32 rows. And how many columns? 11 columns. That is what it says here. Data frame is nothing but 32 observations of 11 variables. If you want to find out what are the names of the columns, you can say more about the data set. You can just say question mark empty cars, and then in the help window, empty cars data set. Empty cars means motor trend car road test. The data is extracted from the 1974 Motor Trend US magazine. It comprises of fuel consumption and 10 aspects of automobile design and performance of 32 automobiles, right? So it tells you what MPG means, miles per gallon, CYL means number of cylinders, etc. If you want to look at the data set, you can just come to the environment pane and just press this button. And then it's just like any Excel sheet that you have. Okay. Is that clear till now? Is
Yes,
that
sir.
clear till now? Okay. Now I'm going to
Yes, sir.
complicate things a little. We are till now working in a project, you know that we are working in an R script, no, isn't it? We are working in an R script. Okay, let me save this file. The way I can save this file is there is a save button, floppy button. I'll just press on this floppy button, and then it'll just directly say that, okay, you're actually in your working directory now, which is exploring data with R, and you can save this anywhere. But just a rule of thumb, not a rule of thumb, good practices, right? Good practices of programming says that all your code or scripts should be in a folder called scripts, right? Later on, we'll be talking about modular code, what is modular code and how to manage projects and things like that. But for now, believe me when I say that always ensure that all your scripts are at one place, okay? All your data can be at one place. All your plots can be at one place. All your references or articles can be at one place, isn't it? So that later on, when you want to come to that project and look for, okay, which code, you can go to that folder and you can find the code, right? So the way we can do is we can create a new folder within our files pane itself. We can say that, okay, here I can create a new folder called code. You can call it scripts also. I prefer to call it code. You can call it script as well. And then there's a new folder created. As of right now, there is nothing here. But when I save it, I can just go to my code folder and save it. Oh, I need to call it my first R script. And then see in my code folder, my first R script is already here. The reason I'm telling you to save it this way is that I'll close this window. Okay. Now I'm working on some other project. Now I remember that I have to go back to this project once again. So I can just go to this top right button because I know that I've been working on it recently. So whatever project I'm working on recently will be there in this thing. So this is the project I was working on. Now I can just press here. This button will open it a new window, new project. So I'll just open it this way. So one more R Studio thing is coming. And you see, Now, if I want to see what I've worked on, I can go to my, see, there is an R history here. Okay, if you look at what this R history is, all the things that you have ever done in this project is saved here. Okay? So don't worry if your laptop crashes or things like that. Your R history will ensure that everything what you have worked on is here. Don't worry about that. But you see, code is there. My first R script is there. I can just go here, select everything, and I can run it. So all the things happen. All the analysis, everything that we do has come, including the opening the help menu. So it's quite possible that okay, you're coming back after 3 months and you don't know what you did, but this way you can actually come back and see, okay, what did I do, right? Okay, so this is the basics of R script. Now I'd like to introduce you to a new file type called R Markdown. It's called an RMD file. How do you create a new file? You go to this file option or this plus button, press this, and then there are n number of options here. In this, there is an option called R Markdown, right? Once you press R Markdown, it's also saying that, okay, what kind of new Markdown file do you want? Do you want to create a document? You want to create a presentation? You want to create a Shiny document? Or you want to do it from a template? See, when I say document, it will just ask me, okay, the document, do you want it to be HTML, PDF, or Word? You can also say, no, I want a presentation. Okay, what kind of presentation do you want? Do you want HTML options, that is IO slides or Slidely? Or you want PDF slides? Or you want PowerPoint slides? That's also there. If you want to create a Shiny interactive document, that's also possible. From templates, there are a number of things that you can create using R Markdown. For example, the primer tutorial that you did has been created using this Learn R packet interactive tutorial. Okay, you can create a dashboard, test dashboard. You can create advanced PowerPoint presentation, advanced documents. You can write your thesis. You can prepare a business card, HTML. You can create a poster. You can create your resume, thesis, journal documents. You can also create GitHub documents, Australian Journal of Statistics, your JAMA, your Lancet, all your articles formats are also here, right? You can just simply say which format you want and it will automatically create that kind of format for you. Okay. Am I talking sense?
Yes, sir.
Okay.
Yes, sir.
So apart from this, there are other things like, for example, the presentation that you're seeing today is a Ninja presentation by, Sharingen. I'll just, for now, I'll just create an HTML document. Okay.
Okay.
The moment I create a HTML document, it's asking me who is the title, what the title do you want, author. I'll just leave the default for now. But the moment I say that, it is going to create an untitled one. Now this one is red. Earlier it was blue and R was there. Here RMD is there. Maybe you're not able to appreciate that. Maybe in your window you'll be able to see it better. But then you can see that there's a number of some text and some code is there, and you don't worry about all of that now. For now, I will just I will save it. And where do I want to save it? I'll save it in my analysis folder. I'll call this first R&D. Okay. So if I just knit it, okay, there is an option here of a wool and how to knit and things. Knitting means you're trying to, what is knitting? Creating a sweater, no? How are you going to create a sweater? You're going to take wool and you're going to do something and then it is going to become a sweater magically. Similarly, you're writing some things here and then you're going to knit it. And magically what happens is that it creates a, sorry, open another window. It creates a file like this. Are you able to see?
Yes, sir.
Okay. So, untitled, Arun Mitra, whatever, this is an R Markdown document. This is simple formatting. So just like I was using empty cars, there is this cars data set. So the moment you say summary of cars, it is going to take two the variables that are there in this data set, and it is going to give you the minimum, first quartile, median, mean, and all of that. And you can also say that, okay, create, see here you are saying plot, create a plot of the data set pressure, and then it has created a pressure plot. Yeah, I've introduced you to two documents. One is R script and one is R Markdown. R Markdown, if you see, R script is plain script, right? R script is plain script. There is not much to it. The only thing is that you can have this hashtag symbol followed by a space and write something. When you write this, it is called an annotation or commenting, right? So when you're writing for yourself, you will say, okay, what did I do here? Okay, you are loading your packages. So it's the way to write or comment your code so that later on you can come and you can look at it. However, R Markdown is a little more specialized in the sense that it includes certain text and it includes code chunks as well, and it includes some special kind of this thing, like this two hashtags are there, and two, what does that mean, right? Two hashtag means it's section header, first level header, and three hashtags means second level header. We'll come to all of that. We'll have a session on R Markdown as well. Which includes text as well as code in between, right? It is text and prose. So you can have it in such a way that, okay, I'm now analyzing this data. I've taken this data from here. You can say that this the data has this problem. So I've thought of doing it this way, and these are the packages that I'll be using. So all this you can write, right? And imagine you can write the same kind of this thing as a thesis as well, right? Because everything is text, whatever you can think of, right? For example, this looks a little, weird, and a lot of difficulty. We might be surprised by this, but there's an option called visual here. I'm not going to recommend you to use visual, but for people who are more comfortable with word kind of scenarios when you write documents, it's simple to use word also. So it's like this. If you want to include an image, you can do that as well. For now, I'll just go to pictures. I'll take an image, maybe this or this. I'll just say, okay. I can give a caption or a link. I can have many advanced things I can do, but I'll just keep it here. So this image is included. And now when I knit it, this image is already here. Okay. But interestingly, if you see in my files option and go here in my analysis, it has also created two other things. I earlier had only my RMD file. Now it has also created an HTML. Okay. I can click on that HTML, open in a browser. So this is the HTML that it has created. Okay. But apart from that, it also created a folder called images. And it has automatically brought that image from wherever it is to your working directory, created a folder called images and put it there. Okay. So it's quite smart enough. Okay. So even if you're worried about, okay, I'm not sure where I put my data and images. So if you do it this way, it's quite easy. Okay. So I'll just stop here for a few seconds because I want to see where you are on this. Where are you guys? Are you following?
Yes.
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 Okay.
Yes, sir.
Okay.
Yes,
Do you
sir.
want me to go fast, slow? Is the space perfect?
This space is perfect.
Okay, great.
This case is okay.
Okay. So this is what we talked about, step 0, right? Step 0 is get your documents and data in place. Right now, we didn't have any data, but where did I put my script files? Where, which folder? Yeah, I put my script files in a folder called code, right? My R scripts, right? I put my RMD in a folder called analysis, because that's the analysis that I would do, right? And if I had data, where should I put the data in?
Data file.
Yeah, simple. It's not rocket science, right? If you had a data, there should be a folder called data, and all your data should be there. Okay. Within that data, if you have some clean data, some raw data, some spatial data, some other data, you can have separate folders for each of them, and then manage it equally, right? Is that fine? Can I move on? Okay.
Yes.
Today we'll be introducing to 3 packages. Out of them, I would say that dplyr package has already been included within the tidyverse, right? If you see tidyverse, 8 packages have already been attached when you load tidyverse. One of them is dplyr. Dplyr is a very powerful R package, right? It's used to clean, manipulate, and summarize unstructured data. In short, it makes all your data exploration and manipulation things very, very fast and easy. And you must think, oh, data exploration in R, that means, okay, I must learn to code, right? I must learn all these functions and things, correct, right? But then if you see the way dplyr is written to fit within the tidy way of things, right? So when I say tidy way of things, the input, okay, one question I'll ask you, if you guys answer this correctly, I'll be very, very happy. Okay. What is the workhorse of tidyverse?
Tables.
Correct. Tables are, all what we are saying, this everything is possible in tidy way and tidy data and all of that. It's all possible because of this new file structure, right? This way of, think of it as a data frame, but on steroids, right? If you remember last time, I've shown you that a data frames class is just a data frame, but you take a table and you look at this class, it will say not just a data frame, it's also a table, right? So it's like it has additional properties to it, right? So the workhorse of tidyverse is tables. So what is this dplyr package? It's a powerful package that makes your manipulation and this thing and easy. But the fun thing and the most exciting thing is it is done using simple English kind of very simple words. It's not rocket science, right? For example, if you want to summarize your data, you'll use a function called summarize. Okay. If you want to filter your data, in the sense that, okay, I have 100 people in my data set. I want to filter only those who are above 80 years. So you'll say that, okay, take data frame and then filter it by age, where age is greater than 80. That's what you'll get. And select, what select is doing, it is going to select the relevant columns that you want, right? Relevant columns means relevant variables, right? So if you see the representation, right? The select is just taking this green and blue column, right? Because you're saying, okay, select only green and blue. Whereas in this filter, you're saying, give me only this first 2 rows, right? What summarize is doing that it is going to consolidate all that and say, okay, for example, if you want to find out what is the mean age of women, so it is going to summarize it and it is going to tell you what is the mean age of women, right? Anyway, you need to ask it that way. But then there is one more function called mutate. What is mutate? Mutate is you're going to create one new variable, right? If anybody has worked in Stata before, they would, the gen or generate function is nothing but mutating, right? See, there are 3 data sets. No, this not called, but yeah, which is yellow or orange in color. There are n number of verbs, but you don't have to remember all of them. Simple, there are only, see, there is this rule of 80-20, 80% of the things can be done by just 20% of things, right? So I would say that 90 to 95% of all the things that I do, I only use this, 7 or 8 verbs. I'm saying verbs because that is what they're called, right? They're something that, select is a verb, right? It is going to select your columns. Filter is a verb that is going to filter your rows. Group by is that it's going to group your data. Summarize, it is going to summarize your data. If you want to arrange your data from ascending to descending and things like that, you use arrange function. If you want to join two data frames together or two data sets together, you use the join function. If you want to create a new variable, you use mutate. It's not rocket science, it's very simple. And I'll tell you how each function you can use, right? Now the syntax, right? How do you use this verbs, right? Any verb, you take the verb, open parenthesis, right? See, this, how many of you have done the basics of programming syntax? This thing, I'm hoping that all of you have at least done that, because if you have done that, you'll know what a function is, right?
Yes.
Function is something that it takes something and does something. Okay. Some functions have optional arguments. Some functions have. I think Lokesh, you should either mute. Yeah. Thank you. You can unmute if you want to talk. Yeah. Anyway, so the function that is declare verb. So you can place any verb here. You can place filter, you can place arrange, you can place summarize, you can place select, you can place join, anything you can place. The syntax is going to remain the same, right? It is going, the first thing it's going to take is a data frame, or it is a table here, right? And then what to do? If you want to say filter, then you can say filter by what? Filter by age, where age is more than such, so and so. Or if you want to select, then select what? Select the first two columns, or the columns named age and gender, right? Or whatever you want to say, select this. Or you can also say select all those variables which contains pre, or all those variables which contains post, because you might have in such a way that pre and post, you can have two readings and things like that, right? So all that is possible here. Okay. But then I'm going to introduce you to a better way of writing syntax. Okay. The way I'm going to introduce you is using the pipe. So this is called the pipe in R, especially the tidy way. It's called a pipe. There are many newer variants to it, but just remember that a pipe is like a percentage greater than percentage. There is a shortcut to get this pipe. It is Control Shift M, M for Mogambo. Just like the assign symbol less than minus or less than this thing is called an assign operator. The shortcut for that is Control Shift I. Control Shift. I'll let you know what that shortcut is. There are ways to very easy. The more you use it, the more this thing comfortable you feel. So the way you need to understand this is, if you remember the assignment operator, we said that anything that is there on the right side of the assignment operator is going to be put in a variable or a value of whatever is there on the left side. Correct? Similarly, this pipe operator is going to say that take whichever is there on the right left side, and then do this to it. Okay. This is the original syntax. We are saying, okay, this is the verb, this is the data frame, and this is what you have to do. Instead of that, you're going to say, take this data frame and then do this to it. Okay. For example, if you want to take a data frame DF and you want to filter age more than 60, you can just say data frame pipe filter age greater than equal to 50. And then you want to select only women. And then what you can say is again one more pipe. You can say select gender equals to female. And if you want to say, okay, only those who are diabetics, then you can say one more pipe and then say filter diabetes equals to true, or whatever, right? Whatever variable it is. I hope you're getting the gist of pipe. So now, let us load some sample data. So I'm just loading some WHO tuberculosis data. I'll share this data with you. It's available in the open domain. I've just changed some variables for the purpose of teaching and things like that. But how many of you can tell me how many functions are we using here in this 2 lines of code?
Glimpse is one function.
Glimpse is one function. Great.
3 in total.
Sorry, 3 in total. Okay, good. But then, yeah, I will agree with what you said. Yeah. Just remember that. Okay, just like a pipe operator is a function, it is going to take something and do something, right? Similarly, it is taking whatever is there on the left side and it is putting on the right side. Sorry, right side and putting on the left side. So this is also taking something and doing something. So this assignment operator also ideally is a function. Okay,
Oh,
that is clear. Okay, I'm very happy that you are able to identify 3 functions. Can you name them? What are they?
here, read CSV and glimpse.
Okay, here read CSV and glimpse. Okay. I hope that you all know that in order for this to run, I have to load 2 packages. Okay. The first package I need to load is
Here,
Tidyverse.
and tidyverse.
Here.
Okay, great, great, excellent. I'm very, very happy. But just to be a little more specific, within the tidyverse, there is a package called readr. Okay, readr. So readr has this function called read underscore CSV. Okay, and within the tidyverse, there is this package called dplyr, and dplyr package contains this glimpse. I'm not sure if it's dplyr or tidyr, but yeah, one of the packages contains this. Okay. Anyway, so I'll ask you one other question, and I'm sure that you guys will be able to answer. Where exactly is my CSV data located in my working there?
the root of the directory.
Correct. Yeah, it is there. It is there in the root. Ideally, I should be putting it in a folder called data. Okay. But I have not done that because of some reason. I don't know why I didn't do that, but yeah. And the second thing is that I'm actually taking this. See, this is the CSV file's name. The here function creates the file path, and it is actually taking this file path and running this function to it, which is called read CSV, and we are actually assigning this CSV or dataset to a dataset called TB. Okay, we are naming it as TB. So anytime we type TB, this dataset will come. So this glimpse function puts a very nice picture to it. It says there are these many rows and these many columns. The first column is called country, which is a character variable. The first entry is Afghanistan, Afghanistan, Afghanistan. The second one is a WHO region. It's also a character variable. Eastern Mediterranean region, it's going to take. The third variable is year. It's a double. 2000, 2001, 2002, etc., etc., etc. And population incidence of tuberculosis in 100,000 population. Sorry, yeah, 100,000. What is the number of incidents? What is the HIV percentage? If you see all this data, all the variables are actually written in a which format? Which what is the case? It is the snake case, right? You remember? You remember snake case?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yeah. Just there are small nuanced things, but these are things that you have to remember. Okay. So if I want to look at the first 6 rows of the data, I'll just say head. Head is a function again. Okay. Head TB, and it's going to say, okay, whatever we saw in the glimpse thing, it is going to actually show us in like this thing. It says that, okay, country, WHO region, so and so, so and so. There are 11 more variables, HIV incidence, which is double, HIV number, double, and all of that. Okay. Just like we looked at dimensions, right? How many rows and how many columns? If you go back, these many rows, 3,850 rows, these many columns, 18 columns. Similarly, it's saying this, correct? And names is going to tell me what are all the variables, names, right? One means this is the first one, second, third, fourth. So it's going to give you only the index of the most left one. Okay. Don't think that there are only 16 left or nested or not there. Okay. In order to, okay, I introduced you to this concept of pipe, right? So you might be thinking, my pipe, I could have just written it properly, and I know how to write it and things. So I'm trying to find out in the bottom 50 rows of this data set, how many countries are there? Okay. The way I do that without using pipe is I'm going to say, take the tail of TB, and instead of 6, when I don't give any number, like if I said head, right? When I said head, how many rows came? First 6 rows came. Because the default n for this function head, if you don't give anything, is 6. But you can override the default by specifying that, okay, I'll give my own n. Okay, give only 10, give only 30, give only 50. Okay. So here I'm saying that, okay, give me the tail of this data set called TB, where n is 50. And then I'm asking, from this data set now, take the column country. And out of this, because I'm asking now 50 rows, right? You give me 50 rows and I'm asking the country, so it will give me 50 entries, and I'm only I want only the unique country, so I'm running a function called unique. This might look like it's a single line of code, but it's very difficult to decipher. Because I have done it, it's easy for me, but if you read it, you'll be like, what is this? But now come to the second line, okay, second way with the pipe. What does pipe do? Take this and do that, right? So it's going to take TB, and then it is going to give me the tail. Tail, how many? 50 tails. And then it is going to find out what is the distinct number more systematic rather than this, at least to me. You might feel that this is only 1 line of code and this is 3 lines of code, but this is more readable, okay, human readable. Okay, this is one of the good ways to do it. And the other reason why you're asking you to use this pipe is that the output also is tidy, in the sense that the output also is a table. If you see the first way, when you're asking, it is giving us a character, right? It is saying that Yemen, Zambia, and Zimbabwe. But when we asked it using the pipe, it gave us the same output, but in a table, right? So not only the code looks tidy, the output is also tidy. I hope I'm making sense. Yes or no?
Yes, sir.
Yes, sir. But I have one doubt, sir. That
Yeah, sure.
that the first function without pipe, there is a function called unique, no, sir?
Yeah.
Unique. Why that is changed distinct in the with pipe, sir?
Okay. The input for any function has to be kept in mind. Okay. For unique, the input is a vector.
Okay.
Whereas for distinct, the input is a table.
Okay.
Okay. Because the input is a table,
Okay.
the output is also a table.
Okay.
Okay. If you write unique here, it will say, no, I could not find unique. I know unique. The input for unique is not a table.
Okay.
Sorry, is not a character, or is not a vector, right? You get my point. Unique
Yes, sir.
takes an input of a vector. whereas distinct takes an input of a data frame or a table.
Yes.
Okay. I'm happy that somebody is asking questions. Okay. Yeah, this is the explanation I was trying to do, but you all got it. So yeah. Now the difference between unique and distinct and count. I'm just because see, I've slightly introduced you to 3 different functions already, right? You already know head, right? But I have introduced you to tail here. I've also introduced you to the unique. I've also introduced you to distinct. Okay. Okay. But I'm also going to introduce you to one more function called count. So how is it different from distinct? So I'm going to give an example of the first code on the left side. It's going to take a table, which is TB dataset, and then it's going to ask, I'm asking it, what are the distinct WHO regions? So it's going to say, okay, there are 6 different distinct WHO regions. You know, the first one is EMR, Eastern Mediterranean, European, African, Western Pacific, American, and the Southeast Asian regions. There are 6, so 6 has come. But the same thing instead of distinct, if I ask count, it is going to count how many entries are there in each of the region. So the total here, for example, African region is 835. American is these many countries are there. It's not just countries actually; it's how many rows. If you remember how many rows were there, somewhere around 3,900 or 800 something was there, right? So this total will make 3,900 whatever rows. Okay, and this has happened. It's also created. See, the table is now having one more column here, which is n. There's a new column that is created. And it's also telling that this is an integer. Okay, the n column. Is that clear?
Yes, sir.
Okay, can I move ahead?
Yes, sir.
Okay. Now I'll be introducing you to one additional function, which we already talked about. It's called arrange. And arrange does what it sounds, right? It'll arrange things. For example, you're saying, if you look at the previous slide, the count function has actually arranged the WHO regions in terms of alphabetical order, isn't it? But imagine I don't want it in alphabetical order. I want how many entries it has, those many. I want that first, right? So I can say, okay, take tuberculosis, count the number of regions, WHO regions, and then arrange it. By what? By n. So n is the column name. If I would have said arrange it by WHO region, it would have arranged it by alphabetical order again. But I'm saying arrange it by n. So when the default arrange will use the ascending order for arranging. So the least number of entries in this data set were for Southeast Asia, then followed by Eastern Mediterranean, then Western Pacific, American, African, and European. Okay, European has 967 entries. Okay, not countries. But if you want it the other way around, you can either use the descending, or you can just say minus n. Usually, what happens? Oh, sorry. I can just say arrange minus n. Instead of just n, I can say minus n. The same result would have come. Okay, is that clear?
Yes, sir.
Okay, so head, tail, glimpse, then what else?
Arrange.
Arrange,
Count.
count,
Distinct.
distinct,
Unique, sir.
unique. Great, excellent, excellent. Yeah. Okay, now I'm going to complicate things a little further. Okay, because I know that you guys will be able to take it. Are we off time? Oh, we are only 10 minutes left, huh? Okay, anyway. So there are some logical operators. Okay, this slide is not really easy to read, but then just understand that the way you want to say is something equal to something. If you want to say that is WHO region equal to Southeast Asia, SEA, then you use these two symbols. I'll show you what that really means, but there are something called as logical operators as well, right? So the output of this logical operator is true or false. So is something equal to something? Yes or no. Is something not equal to something? Yes or no. Is something greater than something? Yes or no. Is something greater than equal to something? Yes or no. You get my point? These are all logical operators which the output is Boolean, right? It's either yes or no. You can combine these logical operators by saying, okay, either this or that, or you can say this and that, right? So there are two things, no? And or. And you can, for the and, you can substitute it with this and symbol. For or, you can substitute it with this bar symbol, which is just above your enter button. So for example, I want to use the function filter to find out all the entries which are above the year 2015. So the way I do it is I take tuberculosis, pipe it, and then say filter it by year, where year is greater than or equal to 2015. So you see, year is 2015. If I would have said just greater than, then this 2015 would not have been there, only 2016 would have started. You get what filter is doing? Do you guys get what filter is doing?
Yes, sir.
Okay. Filter means it is filtering the columns or rows.
Column.
Rows.
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 The reason is, see how many rows it has. How many rows does it have? 3,850. Okay, this is the total data set. How many columns? 18 columns. Clear? Now when you're filtering it, how many rows and how many columns? Columns are same. Columns are 18 only, but rows have reduced, isn't it? So keep in mind, filter
Yes, sir.
will take filter will only take the rows which qualify this Boolean argument, right? This is a logical argument. Is year greater than or equal to 2015? If year is greater than 2015, then only you give me this entry. Otherwise, don't give. Okay? We can. This is using a number. Now we can also select it by other variables also. Like for example, if country is equal to India, we cannot use one single equal to. We have to use 2 equals to. Okay? 2 equals to. This is something that is very inherent to logical operators, right? Yeah, there are only 18 entries, 2000 to 2018, and only India has come. See, 18, isn't it? So now, by using this, where year is greater than 2015, greater than or equal to 2015, and country is also India, right? So this AND operator is doing that. This also has to satisfy, that also has to satisfy, right? So then you get only 3 entries: 2015, 16, 17. Clear? For India, okay? No, you see only 3 of them are there. All the columns are available, but only 3 rows have been selected or filtered. Okay, is that clear?
Sir, I have one question.
Sure.
In the filter option, for year 2015,
Yeah.
it is not inside the inverted comma, but in country,
Yeah.
India is inside the inverted
Yeah.
comma. So why?
Yeah. Yeah. If you would have seen, the color for 2015 is actually selected as blue, right?
Yes, sir.
India is in red. That means it is saying that, okay, this India, whatever you are saying, is a string variable. String, right? String, nominal, string.
Yes, yes.
Whereas this 2015 is a numeric variable, isn't it?
Yes, sir.
So for numeric variables, you need not give this string, this inverted commas. If you give inverted commas, it will consider it to be a character variable, right? See, if you see, country is a character variable, whereas year is a
Yes, sir.
numeric double variable. Double means anything that can have decimal points also, but it is numeric. Double means also numeric. Okay. If you would have put
Okay.
inverted commas for this also, then all would have been selected, or some error would have come saying that, okay, year is not a character variable. Get my point?
Yes, sir.
Maybe you can try it and see what error is coming later on. Okay.
Yes, sir.
I want to introduce you to one more complication. We have looked at the pipe operator. No, it is taking percentage greater than and percentage. What it means is take this and then do that, isn't it? So there is this in operator also. For example, if we want to select all the countries that are there in Southeast Asia, or if you want to select India, Nepal, Pakistan, Bangladesh, okay, how we do that? First, we need to find out, okay, how in the spelling of India in Nepal and Pakistan and Bangladesh, is it correct? Okay, and then we can just do it this way. See, I'm creating a new variable, new vector, not a variable, new vector called Indian subcontinent, and I'm assigning it something to it. Okay, I'm assigning India, Nepal, Pakistan, and Bangladesh, and all these are separated by commas. This 3 commas for 4 variables, and this whole thing is there in a bracket with a function called C. Okay, C means concatenate or combine. You can think of combine all these things together, right? So combine these 4 countries and put it in a vector called Indian subcontinent, and then you look at this. I'm saying take this TB, and then pipe means and then filter where country is in this subcontinent. So then it will see, okay, is country India? Yes, okay. Then I will give that. Is country Pakistan? Yes, okay. Then I will give that. Is country Nepal? Then it. But if you see, only 72 countries are there. Okay, that means India, Pakistan, Bangladesh, Nepal has been repeated 18 times each. Okay, is that clear? You'll come
Yes.
to know once you use it, but I'm just trying to introduce you to these verbs. I don't want you to feel, oh, jada too much coding ho gaya hai. But it's all simple. It's not rocket science. It's just English verbs. Okay. There are some other useful functions. What is drop NA going to do? It is going to remove missing values from your data set. You can specify which columns you want to say use to remove those NAs also. That is also possible. Select function, just like filter function is filtering the rows, select will select the columns. So you can say that, okay, I want the first 10 columns, first 5 columns, or you can say, give me age, gender, and then status of diabetes or hypertension. So those only will be selected, right? It's possible that out of all, you might collect 100 variables, but you only need 5 or 6 for this particular analysis. Then why would you need all that to load, right? You can select this particular thing. So summarize function, what it is doing is you take this data set and you say summarize. For example, summarize, I want the mean HIV percentage. This is the default argument, na.rm equals to true. For example, if your data set has na in between, it will give you an error. It will say, okay, the mean is also na, because it is trying to divide by something that is 0. Okay, but you can say, okay, remove all those entries where na are there, and then give me the mean, and then you can say, okay, give me. And so the output is also a table here. You'll use this summarize function again and again, and the more you use it, the more comfortable you'll become. Similarly, this group by is right now, it is not going to do anything here. It is still these many rows and these many columns, but it has also created one other thing saying that it's grouped by year. So any summary you'll do, it will be grouped by year. Okay. So you can use multiple variables to group by. For example, group by year and WHO region. That means 6 WHO regions into 18 years, that is 108. Okay. And then you can say, okay, group by year and summarize the mean incidence. So by year, 18, the different 18 years, you're creating the mean incidence, right? Is this clear? Or am I going too fast?
It's clear, sir. The face is perfect.
Okay. So we already talked about this mutate function. What is mutate doing? Mutate will add new columns, right? For example, we are saying that, okay, add one A and B, and then it is going to create a new column called C, where this and this is 3, 5 plus minus 3 is 2, 10 plus 4 is 14, 0 plus 9 is 9, and whatever plus 6 is 8. That means here the thing is 2, right? So this is what mutate is going to do. So there is this if else function. If else is that it creates a new variable. For example, if this satisfies, then this, otherwise this. For example, we are trying to create a new variable called Indian subcontinent 1. We are saying that, okay, if country is within this variable, Indian subcontinent, if you remember, we have created that, right? There are 4 countries that we put: India, Pakistan, Nepal, and Bangladesh. We're saying that if country is within these 4, then you call it Indian subcontinent. Otherwise, you call it others. Okay. There are a number of variants of if else. One is a case when. So the idea is that if you have only 2 things, like if this, then do that. If it's only 2 things that you need to do, if else is fine. But if it is more complex, if you want to say that if age is greater than less than 1, call infant. If age is less than 5, then call under 5. If age is less than 10, then under 10. If age is less than 24, then youth. If those too many if else are there, then a better way of writing things would be a case when. Okay? We will see that what case when is doing, and there are slight changes in the syntax. Otherwise, it's the same. Like, for example, case when type is Kraken, then you say the danger is extreme, otherwise it is high. Otherwise, danger is high. Right? Because Kraken, Dragon, this is just an example of things. This is an example of when to use a case when and when to use if else. Just I told you that if there are only 2 options you need to use, then if else is better. Otherwise, if there are more things, then you would like to use case when. The other resources that you have is, I'll be sharing this with you. There are more resources on dplyr. I'm sorry, actually, I have my daughter with me. Okay. 8:30, is it? Okay. Yeah, anyway, I'll share some of the resources just like I did last time, yesterday. Just have a look at that. And there are some 2 other packages that I'd like to introduce you to. One is the Skimr package, and the other one is the Data Explorer package. There are only one function that you need to use from each of those packages: the skim function from the Skimr package, and Data Explorer or create report function from the Data Explorer package. Yeah. So there is only one function that you need to use: create report. What it will do is why don't you? I'll share. Sorry. Yeah. What I'll do is I'll share these slides with you guys, and I'll share the data set that we are, working with, the TB data set. And maybe you guys can use the skim function on this data set. For example, the way you need to write would be skim bracket open TB. Okay. Or what you can do is you can say TB pipe skim, isn't it? What pipe is saying, you take this and then do that. Take the TB data set and then do the skim function on it. Similarly, if you want to create a report, you would like to say, take this data set TB and then create a report of it. I'm sure that once you use these 2 functions within your RStudio, you will be really amazed of about how much can be done in how much little time. Okay. I'm sorry for saying let's begin, but it's I think let's begin is for you. I'll be sharing this maybe tonight itself, and maybe now we can I'll just stop now, and we can have any questions if you guys have. We can just discuss that.
No questions.
No questions? Predicts are joined, huh? Okay. Could you get something, sir, or I did not notice when you joined?
No, I joined 7:20.
Okay. I hope that was a little clear,
Yes,
though
yes.
you were not here last time.
No, I was the last time also.
Okay, sorry.
First year.
Yeah. Okay, then I'll share the I'll be sharing the video like last time and the resources and the slides and the data set, and maybe you guys can have a look at it. Not that slide, huh? Okay. Okay then. Any questions?
Sir, when will be the next class?
Tomorrow.
Oh,
Tomorrow, no?
Yes.
Isn't it? Yeah. Tomorrow, is that okay with you guys? Tomorrow?
yes, sir.
Okay, great. Then see you then. Yeah. Have a great night. Yeah. I'll send
Thank
you
you.
tonight itself. Yeah.
Thanks.
Good night.